We're in the middle of a computing revolution that is unlike anything we have ever seen before. Seriously, there's this tidal wave of demand, an AI tsunami that's just crashing over the entire tech industry. And it's all being driven by one thing: artificial intelligence. So in this explainer, we're going to break down why this is happening right now, what it really means, and where this is all going.
So here's our game plan. First, we'll talk about this massive surge in demand. The industry is calling it the inference inflection point. Then, we're going to dig into the cause, how AI is evolving into these powerful agents. After that, we'll look at the incredible new infrastructure being built to handle all this, the AI factory, and unpack the totally new economic model that it's creating. And finally, we'll look ahead and see what this all means for our future. All right, let's jump right into the heart of it. Something fundamental in the world of AI compute has shifted. And honestly, it happens so fast, it's giving everyone whiplash. The tsunami is here. Just look at this number: a 1 million-fold increase in computing demand in just 2 years. And no, that is not a typo. This absolutely insatiable demand is being felt everywhere, from the biggest cloud providers all the way down to the smallest startups. It's the real reason GPUs are so hard to get your hands on, and it's why we are witnessing the single largest infrastructure build-out in human history. This quote from Jensen Huang just captures the moment perfectly. We've crossed a line. For years, the big conversation around AI compute was all about training the models. But now, the whole game has changed. The real work, the thing that's causing this absolute explosion, is something else. It's called inference.
So it's really, really important to get this difference. Think of training like sending an AI to school. It's this huge, one-time effort where it learns everything. But inference, well, that's the AI graduating and getting a job in the real world. It's the model actually using its knowledge to think, to reason, and to generate stuff for us. Text, images, code, you name it. And every little piece of that output is measured in things called tokens. Doing that work in real time for millions of us at once, that's the workload that's now 1,000,000 times bigger.
Okay, so if inference is the what, then AI agents are the why. The reason inference demand went completely vertical is because we've changed what we're asking the AI to do. It's not just about getting answers anymore, it's about getting things done. This whole evolution happened at a breathtaking speed. First, AI learned to perceive the world around it. Then, it learned to generate brand new content. That's what we all saw with things like ChatGPT. But these last two steps, these are the real game changers. Reasoning lets an AI plan to break down complex problems. And that do phase, that turns it into an agent that can actually go out and execute those plans, completing tasks with multiple steps. Each jump up this ladder requires way, way more inference. And this just nails the new reality. We've shifted from a retrieval model, like a search engine, to a generative agentic model. Instead of just asking for an answer, we're giving the AI a goal and telling it, hey, you figure out the steps and you go do the work. This is agentic AI, and it needs a constant, intense stream of inference to function. So a 1,000,000-fold increase in demand, that requires a totally new kind of infrastructure. The old way of doing things in computing just can't keep up. It's not even close. So the industry is building something new, from the ground up, the AI factory. And the engine powering this AI factory is a concept called accelerated computing. You see, for decades, we all relied on Moore's Law, the idea that CPUs would just get faster and faster every couple of years. Well, that era is over. Accelerated computing uses specialized processors, like GPUs, to deliver these insane targeted speedups, letting us make these giant leaps in performance right where we need it most, for AI. And this timeline just shows you the incredible breakneck pace of this innovation. In just 10 years, we went from the very first AI supercomputer in a box back in 2016 to the upcoming Vera Rubin platform. And in that time, the amount of AI compute available has shot up by an astonishing 40 million times. The whole scale has shifted from thinking about a single server to entire data centers that act as one giant computer. This is exactly why the factory analogy is so perfect. These aren't just buildings that store our data anymore. No, they are active, humming production facilities. Their raw material is data and electricity, and their finished product is intelligence, delivered to us in the form of tokens. Now, when you build a new kind of factory, it runs on entirely new economic principles. The old ways of measuring cost and performance, they're being completely thrown out the window. The most important metric for any factory is efficiency, right? For an AI factory, that means tokens per watt. Every single one of these facilities has a fixed power budget. So the whole game is to squeeze out as much output, as many tokens, as you possibly can within that budget. And this chart shows how each new generation of architecture, from Hopper to Vera Rubin, delivers an exponential increase in that throughput for the same amount of power. We're not talking small gains here. These are gigantic leaps in efficiency. Now, let's look at the other side of that amazing coin, the cost. Because the throughput per watt is going through the roof, the operational cost to produce every single one of those tokens is plummeting. This is the magic of accelerated computing. You're not just getting more intelligence, you're getting it for dramatically cheaper. So even if the hardware itself seems expensive up front, the cost of the actual product, the token, is in an absolute freefall. And this just sums up the new economic reality perfectly. We are past the age of Moore's Law, where we measured everything in gigahertz. The new fundamental commodity of the digital world is the token. And the most important question is, how efficiently and how cheaply can you produce it? So we've got this massive new demand, a new type of factory to meet it, and a brand new economic model. But what does all of this actually mean for software, for businesses, and even for our jobs? How does this change everything? Okay, get ready for a new acronym you're going to hear everywhere. AGAS. Just like software as a service, or SaaS, defined the last era of the internet, agentic as a service is going to define this next one. Companies won't just be selling you a tool and expecting you to figure it out anymore. Instead, they'll provide intelligent agents that use those tools to accomplish your goals for you. So what's the spark that's lighting this massive fire? It seems to be a project called OpenClaw. The best way to think about it is like the operating system for this new agentic world. Just like Linux gave us a free, open foundation for servers, or HTML did for the web, OpenClaw is providing a standard framework for building AI agents. It's being adopted like wildfire, and it's enabling the entire industry to build on top of it, creating this incredible explosion of new agentic software. And that brings us to the final idea here. In the very near future, professionals, I'm talking engineers, artists, scientists, everyone, they won't just have a salary. They'll have a token budget, an allocation of compute power for the AI agents that will amplify their work by 10 times, 100 times, or even more. The question is no longer just what you can do, but what you and your team of AI agents can achieve together. So, what will you build?